Hello everyone. This video will be studying about the mechanism of flow charge and flow of charge in metal. Of flow of charge, how charge flows in metal. Firstly, the first term that comes the electron. So now in metals, outermost electrons will experience force. Okay, so this is the outermost shell. Okay, electrons are here. These electrons will experience force. Okay, so these outer electrons can be removed easily from the atom simply by rubbing or heating. These electrons can be removed from the metal, okay, by rubbing, or you can say by providing energy, okay, or heating, okay. In fact, if outermost electron leaves their atom and move freely in the vacant space between the atom, these electrons are called free electrons, okay, or conduction electrons. Means the electron which gets freed from atom due to rubbing or heating, you can say, okay, which moves freely in the vacant space, okay, between the atoms. These electrons are called free electrons, okay, or conduction electrons, right? And uh, one more term that comes, electrical conductivity. Okay. Basically, due to these free electrons or movement of these free electrons, or you can say conduction electrons, electrical conductivity of a solid depends on number of electrons in it. Okay, greater the number of free electron density, greater will be the conductivity. Means if n is free electron density, if it will be higher, then electrical conductivity, this will also be higher. Means the number of free electrons depends, sorry, the electrical conductivity of a solid depends on number of free electrons in it. Okay. Now, the next term that comes is free electron density. Okay. This is nothing but number of free electrons per unit volume. Number of electrons, sorry, number of free electrons. Number of free electrons per unit volume. This is called free electron density. For metals, generally, uh, free electron density. See, this free electron density is represented by N. Okay. For metals, free electron density is approximately is equals to 10 to the power 29 per meter. Means 10 power 29 free electrons per meter. And one more data, conductivity. Okay, we'll be studying about this later in this chapter. Okay. Conductivity order of some metals are silver, copper, aluminum, sorry, gold, and then gold. Then this is a conductivity order, and this will also be what, the electron density, because uh, more the free electron density, more will be the conductivity. Right. Now, the next term, that is mean free path. See, this process, this definition of free electrons, you can write on your own. Okay. Okay. Now, uh, just write down these things which I am telling you for mean free path. See, in absence of electric field, free electrons in metals behaves as the molecule of a gas filled in a closed vessel. Okay, means electric field is absent. Okay, then these free electrons, they behave same as the molecules of gas filled in a closed vessel. Okay, so these are molecules of gas. Okay, these electrons in metal behave same as the molecule of a gas in a closed vessel, means just random movement, right? And the motion will be random, and these free electrons move with a very high thermal velocity. These free electrons move, or you can say perform motion with very high uh, moves with very high thermal velocity, right? In the vacant space between the stationary positive charge. Okay, these electrons move with a very high thermal velocity in the stationary, and this thermal velocity is approximately equals to 10 to the power 5 meters per second. Okay, during this motion, the free electrons collide with these ions. Okay, again and again, again and again. After each collision, their direction of motion obviously will change. Okay, both these are the ions. Okay, and these electrons come collide with this. Okay, then its direction will change. Again, it will collide. Its direction again gonna change. Again gonna change. So this is basically a random movement. Okay. Uh, During motion, the electrons collides with these ions again and again, and after each collision, their direction of motion changes. So the mean free path. Now our definition comes. The average distance moved by free electrons between two successive collisions is defined as mean free path. The average distance moved by free electrons between two successive collisions is called as mean free path, and it is denoted by m. Okay. The next term that comes is relaxation time. See, this is mostly a theoretical part. Okay, so you need to know the definitions. Okay, this relaxation time is denoted by tau. Okay, and this is basically average time interval between two successive collisions. Right, this is your relaxation. The next term is average thermal velocity. Okay, average thermal velocity. Suppose, let's say u1, u2, u3, these all are velocities vector. Okay, u1, u2, u3, and so on, un up to un with the indivisible thermal velocity of free electrons. Okay, at any given instant. Okay, if total number of electrons, total number of free electrons is n. Okay, total number of electrons is, let's say, n. Okay, then the average thermal velocity is defined as vector u1 plus vector u2 plus vector u3 plus and so on up to vector un upon. This is your average thermal velocity, right? summation of all the individual velocities. Okay. The next type of velocity that comes is drift velocity. Okay. Now, for defining drift velocity, see, when we connect the ends of a metallic conductor to a battery, okay, means for the metallic conductor, okay, and we are connecting this to a battery. Electric field is produced at every point of the wire. Okay. Now, as a result of this, each electron will experience electric field. Obviously, the electrons will present here. Okay, they will experience an electric field. Okay, and the electric field will set up in this direction. Okay, since this is at higher potential, this is at lower potential. Okay. Now, these are what they all are free electrons. Okay, so they will experience a force. The direction of electric field is in this direction. Electrons which are moving in this direction, they will experience a force in this direction. Sorry, I need to draw the force with red. Okay, let me draw first draw electron. They are moving randomly, right? They will experience force in this direction because they are electrons. Okay, electric field is in this direction. So, electric force. This force will accelerate the motion of electrons opposite to the direction of electric field. The velocity of electron does not increase continuously, okay, because it collides again and again. Velocity, this increase in velocity is not continuous. Why so? Because once there is an increase in velocity, they collide with another electron. Okay, another electron. So this with the passage of time, there is an increase of velocity, and then with the collision, there is a decrease of velocity. Okay, so and you know the why there is not a continuous increase in velocity. Okay, this collision also tends to lose the kinetic energy it has gained. Okay, so therefore the potential difference of battery does not give an accelerated motion to the electron but simply gives a constant velocity, and this constant velocity is approximately 10 to the power minus 4 meter per second, okay, along the length of the wire opposite to the electric field. This velocity of electron is known as drift velocity. This velocity is known as drift velocity, which is represented by vector pt, and its direction will be in opposite to the direction of electric field, or you can say current. So this was drift velocity. Okay. Now one more thing. Okay, in the next video we'll be covering this that relation between electric current and drift velocity. Okay.